about a project titled A Time Frequency Based Suspicious Activity Detection for Anti-Money Laundering. Now coming to the introduction part, the proposed system incorporates machine learning algorithms to classify flagged transactions based on learned patterns of suspicious behavior. As the model is exposed to more data, it can continually refine its understanding and improve detection accuracy. This iterative learning process ensures that the system becomes increasingly effective in identifying potential money laundering activities over time. In summary, the time frequency based suspicious activity detection for anti-money laundering introduces a novel and powerful approach to combat the ever-growing threat of financial crime. By harnessing the capabilities of time frequency analysis and machine learning, the system holds the promise of enhancing AI/ML efforts, safeguarding financial institutions, and protecting the integrity of the global financial system. Now coming to the objective part, our main objective for the project, a time frequency based suspicious activity detection for anti-money laundering, is to provide financial industry with a sophisticated and adaptive solution that bolsters their ability to detect, prevent, and combat money laundering activities, thereby contributing to the integrity and stability of the global financial system. Moreover, the integration of machine learning algorithms within the system aims to enhance detection accuracy over time. By continuously learning from new data and refining its understanding of suspicious behavior, the model endeavors to stay up to date with evolving money laundering techniques, making it a robust and proactive tool for financial institutions in the fight against financial crime. By employing time frequency analysis, the model intends to uncover hidden irregularities in transactional patterns which might go unnoticed using conventional methods. This approach facilitates the identification of unusual activities that occur over specific time intervals, offering a more precise and detailed understanding of potential money laundering schemes. Now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement, Python IDEL, that is 3.7 version, is required for running this project. Now coming to the methodology part, first we have upload anti-money laundering dataset. In this step, the first task is to obtain a relevant dataset containing historical financial transaction data. This dataset should be specifically curated for anti-money laundering purposes, meaning it includes information about various financial transactions that might be associated with money laundering activities. This dataset may include attributes such as transaction amounts, timestamps, account numbers, transaction types, and other relevant information. Second, pre-processed dataset. Once the dataset is obtained, it needs to be pre-processed to ensure it is suitable for analysis and model training. Data pre-processing involves tasks such as cleaning the data to remove missing or handling outliers and converting categorical values into numerical representations. The data may also be normalized or standardized to ensure all features are on a consistent scale, which can aid in model performance. Third, run random forest with transaction. In this step, a random forest algorithm is applied to the pre-processed dataset. The random forest is a machine learning ensemble method capable of handling both classification and regression tasks. Here, the goal is to use the random forest algorithm to classify transactions as either normal or suspicious. The model is trained on the historical data where the target labels are known, so it can learn to recognize patterns indicative of money laundering. Fourth, run with transaction and time frequency. This step involves enhancing the initial random forest model by incorporating time frequency analysis techniques. Time frequency analysis aims to decompose the transaction data into its time and frequency components, allowing for a more comprehensive representation of the data. By capturing both the temporal and spectral characteristics of financial transactions, the model becomes more adept at identifying subtle and time-varying patterns associated with money laundering activities. Fifth, comparison graph. Once the models have been trained and evaluated, a comparison graph is created to illustrate the performance differences between the two approaches. That is, random forest with transaction data only versus random forest with transaction and time frequency data. The graph may display metrics such as accuracy, precision, recall, and F1 score for each model, offering a visual representation of their respective detection capabilities. 6. Predict money laundering from test data. After training and validating the models, the next step is to use the best performing model to predict money laundering activities in unseen or test data. This test data contains transactions for which the label is withheld during training. By applying the model to this new data, the system can predict which transactions are likely to be involved in money laundering, providing valuable insights to financial institutions and regulators. 7. Close application. Once the predictions have been made and the comparison between models has been evaluated, the application or system developed for this analysis can be closed or terminated. The results obtained from this process can be further analyzed and any necessary adjustment or improvements can be made to enhance the performance of anti-money laundering detection system. Now coming to the execution part. To execute the project, first we need to open the code folder. There we can see a folder named as dataset. It is containing the training dataset and the testing dataset. Here, the suspicious money laundering detection is a Python file which is containing the Python script in it. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on the run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. Now click on upload anti-money laundering dataset button to upload dataset for getting the out. Here I am selecting this dataset. Now click on open. Here we can see dataset loaded, and dataset contains some numeric and non-numeric data. So we need to pre-process data to convert into numeric. And in this graph, x-axis represents labels, where 0 means normal transaction and 1 means money laundering transaction, and y-axis represents counts. Now closing this graph, click on pre-process dataset for getting the out. Here on the screen we can see dataset converted to numeric format, and in last two lines we can see dataset contains 2001 records and each record contains 11 features. And now dataset is ready. Now click on run random forest with transaction button to train random forest on transaction dataset for getting the out. Here we can see random forest on transaction data. We got F score as 32% and true positive rate as 0. So transaction data features will not allow random forest to train perfectly. Now click on run with transaction and time frequency button to convert transaction data into time frequency, and then retain random forest to get the output. Here we can see that the random forest with time frequency transaction data got 94% F score and TPR as 45%. So by converting transaction data into time frequency, we can build accurate prediction model. Now click on comparison graph button to get the graph. So here on this graph we can see x-axis represents technique name, whereas y-axis represents F score, and in both techniques time frequency got high F score. And now closing this graph, click on predict money laundering from test data button to upload test data for getting the output. Click on test data and click on open over here. Here we can see transaction test data in the square brackets, and after arrow symbol we got prediction output as normal on money laundering. So completing with this project, and now coming back to the conclusion part. In conclusion, as financial crime become increasingly sophisticated, the importance of advanced detected systems cannot be overstated. A time frequency based suspicious activity detected for anti-money laundering offers a powerful solution that equips financial institutions with the tools they need to proactively identify and combat money laundering, ultimately contributing to a safer and more transparent financial landscape. Its potential impact on AML efforts holds great promise for a future where illicit financial activities are mitigated and the integrity of the financial system is upheld. The integration of machine learning algorithms in the detection process ensures continuous improvement and refinement of the model's capability. By learning from new data and adjusting to emerging trends, the system becomes more adept at recognizing evolving money laundering strategies, while steering its effectiveness in the long run.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.